Rice is a really important staple food, and for half the world's population, rice is their main source of calorie intake, especially in the poorer countries and in Southern Asia. You always think of rice fields as these flooded fields, flooded paddy fields and rice growing and people transplanting, and it's true actually, 70% of the rice is still grown like that. It's using a lot of water. But another big problem is greenhouse gas emissions. So because the field is flooded, you have a lot of bacteria in the water, and these are methanogenic bacteria. So they produce methane. And as we all know, methane is one of the 3 greenhouse gases that we really don't want. However, rice is not a thirsty plant. It's no more thirstier than wheat, for example. So if you grew rice like you grow wheat or maize or corn, you drill it in the soil, you irrigate it, it'll grow fine. Rice breeders have never selected for traits that are important when you do direct seeding. And that's sort of what we've started out to do. So what are these traits? Essentially, when you put seeds in a soil, what you really want is for that seed to germinate really quickly, rapidly establish itself, come above the soil and start growing fast.
We are focused on the very early stage of elongation of the shoot, what we call mesocotyle, and also the elongation of the root. So both parts of the seedlings basically, because they are both critical for the establishment of the seeds of the plants in the field. Once we measured that trait, that character in all the collections that we are studying, then we use a technique called GWAS, which is a genome-wide association analysis, and that basically brings together some genetic information that we already have from previous work and the trait that we measure, and we basically look for correlation between those 2 factors. And it basically speeds up a lot the process, because we can go directly or almost directly to the genes that is specifically controlling the character that we are studying.
We screened close to 1,000 different rice varieties, and we established a new system, in-house laboratory system, so we can have it under very controlled conditions, and we tried to follow germination of rice in these very early stages.
The plants are sensitive to light, but not all light. So we can kind of trick them, because if we manage to set a flash of light at a specific wavelength that basically the plant don't see, then we can image without being seen. In the past, breeders would have basically crossed different varieties and pick up the best performers, the fastest establisher in the field, and then bit by bit build up that character. The way we do it is much faster, because we use those genetic markers to go directly to the important part of the genome that is critical for improving that trait. It's kind of pick and mix rice, if you want.
If you can get a farmer to grow some direct seeded rice, even as a trial plot, neighboring farmers will come and say, he's got that growing really well, I want the same. And I would not dream of doing that, because I'm a scientist, I don't really know how to farm rice. And this is where we talk to our partners. And I think it's really important that we work with the people that the farmers trust. And I'm hoping perhaps in the next few years, some of the varieties that we had a small part in could be grown by farmers in Southern Asia.